Hello, everybody. It is Friday, June 29th. This is our bi-weekly SIG AWS meeting. I am your host or co-host today, Justin Santa Barbara with Google, and we have a fairly full agenda. Please, if you do have things you want to discuss, do make sure they are on the agenda. Otherwise, let's just dive in, and I think our first item is about pod IPs with NLBs. And Micah, I presume you added that. Do you want to take the floor for a minute? Oh, you are muted, Micah. Oh, something. We can go to the second item and come back if you'd like, an extra minute, or.
There we go. Okay, great. Two different mute buttons. So yeah, thanks. So one of the things that we've had customers asking about is basically the ability to use like a network load balancer in combination with the VPC network. With our CNI provider, it's on the VPC network, same network as the nodes. So why not directly route to pods instead of nodes? So that's something I wanted to sort of bring up for discussion. As I filed a issue last night, kind of thinking that it could be in similar thoughts or similar to the current NLB implementation, but one difference is that instead, I think the current update cloud provider gets called whenever there's a node change, but not when there's an endpoint change on a service. If the service itself has changed, like a port has changed or something like that, or annotation has changed, the cloud provider will call update load balancer service, but I don't believe that happens. So it might need to be an out of tree thing. Didn't know if you had any input on that, Justin.
Yeah, I mean, it sounds like a great idea. I think the big gotcha with these sort of things in the past has been if the cloud provider, that the AWS or GC or whatever your backend is, can't effectively keep up or has a latency, that the behavior could be awkward. But I mean, I presume with like NLB, it's okay. And so it would, I think it would be great to do it out of tree, at least initially as a prototype. Whether it goes into the Cloud Controller Manager or in tree, I don't know. I would also suggest it'd be great to get it in some way that's generic, right? I don't know if that's practical, but it feels like there's the Lyft CNI provider, which is sort of similar to the, sort of similar functionality. And so if there's some way we can make it be something that could be used generically, I think that would be great. I don't know whether all services would use it. Presumably not. Presumably you have some annotation. And I think there is today an annotation for, what is it? Local services where they open up I think it's on GCE primarily, where with a load balancer you can open up a second health check port and the traffic will skip nodes that don't have any pods running on it. So it avoids some of the traffic, some of the hops inside the cluster. So that sort of approach might be nice in terms of how the annotation is expressed. But if you can do that, I'd love to see it. I think it could probably live outside of tree. Outside of Kubernetes, certainly. But we now have plenty of repos within, AWS repositories and external. So I don't think, I'm not saying go do it on your own, go do it somewhere else. I'm saying but you don't necessarily have to bottleneck on KK.
Sure. I think I'll probably do a prototype out of tree just initially because of the needing to update on endpoints, not just node updates. And then I think sort of the point of this is also to bypass kubeproxy entirely. So not use either local or cluster. It might just be, I don't know, a CRD instead. I don't know. More discovery, I guess, to actually get that correct. But
yeah, definitely check that out. There's definitely we're starting to get towards like Ingress and the sort of similar feel there where we have these. So Ingress is currently one big API object, and we're thinking about like how to split it or how to provide all these different implementations. And so yeah, your experimentation on CRDs or not will be very interesting. I think I personally would probably do it keep it as a service that's of type cluster IP. and then have an annotation that triggers your behavior. So you don't have to like,
Okay. Sure.
At least to date, all services are like a load balancer service is still accessible inside the cluster.
Right.
And so that would be through kubeproxy or IPVS or whatever it is, right? So
That does make sense.
I mean, yeah, I guess. So
no, that's a good call. I think, yeah, that's doing just an annotation on the cluster IP for now, but with the expectation that it's actually a load balancer service, even though it's called cluster IP. Yeah, okay, that's a good call.
I mean, yeah, and then if you want to collaborate with people and have it as a SIG AWS repository, I think that would also be another great one to do. But might as well do a little experimentation before we go through all the pain, as it were. Less pain, still some work. Yeah, but that's great. That's a cool idea, actually.
Hey, Justin.
Oh God. Are you?
Yeah.
Okay. I had a quick question. Could you just explain a little bit of how local works? I'm guessing when you turn the service.spec external traffic policy to local, that's when services with endpoints will remove themselves from the list of nodes eligible for the traffic. Is that how it will work?
I might not be the best person to explain, but my understanding is it's sort of a trick to avoid having to reprogram the load balancer all the time. We sort of create a secondary port, and there's a health check, because health checks are much faster than reprogramming the sort of control plane. I don't know if anyone else has more experience than Micah.
Yeah, so this is built into NLB, actually. ELB doesn't have this support, but NLB does, where you can say local, and the NLB health check won't hit the service port, it'll hit a health check port and only route traffic to that node if there's a pod for that service on it.
Yeah, and so this is relevant to the ELB discussion we had yesterday, same conversation.
Mm-hmm.
One thing we discussed that local also means, suppose you had similar nodes, multiple copies of the same node, the same pod running on one single node, then you wouldn't have even distribution of traffic.
Yep, that's the trade-off.
That's the. Does that make sense?
It does make sense. And my guess is, with Micah's suggestion, though, if we're routing direct to pods, you would. I mean,
Yeah,
it's
that's probably,
Yeah.
probably go with. Okay. So yeah, this was a customer issue raised for ALB as well, and I think the solution would be easier to implement on ALB.
I think I like the pod approach. We could probably implement local in a different way than a health check if you have a backplane that can reprogram fast enough and supports weights. But otherwise, I like the pod approach. The pod approach seems like a nice one to investigate. It seems like it's the next step on the like CNI. It feels like the logical next step for that CNI approach that you guys are working on.
And so since this only works with the Amazon CNI, is the best way to trigger turn behavior on and off if it's using the same code? Would that be to use an annotation, or is there another way that would be better?
I would prototype it with an annotation to start, and then we can like see where it goes. I don't know whether there are actually any other CNI providers out there. I mean, I know that the Lyft one is similar, but I don't know of even those two whether there's more. And
yeah. So this is specifically work for CNI providers that use the VPC native IP addresses, right? So for overlays, you have to use the existing behavior because overlays are technically not part of the VPC network. So NLPs are not able to reach, which is why it's going through the node port. So I want to wager that the KubeNet might work, but it's still TBD to figure out whether this change is okay with the KubeNet approach as well.
But this would also work kind of generically if you had, basically the requirement is that your load balancer can address pod IPs directly, which is true of this CNI plugin in AWS, but is also true of like bare metal Kubernetes with like Calico in layer 3 mode. Like there's lots of ways that you can achieve that. So
Agreed. Agreed. Yeah.
Yeah, that's and so in the PR it
Just to
just said
clarify,
it's
Calico with something like an overlay would not probably work, right? Like for a
Right.
multi.
yeah, exactly.
Right.
yeah in the issue I raised I just said yeah our CNI provider would work with it, or yeah Calico or anything where the load balancer so can be in the same network and is aware of the pod network.
To me, the big question is whether when you're using the AWS CNI provider on AWS, whether you would always use this or whether it would be a option. And I guess that's something we'll discover when Mike does the work and like we see like if there are any shortcomings or whether it's just like better across the board, as it were.
Right.
Yeah.
Awesome. Shall we move on to the next item? Yeah, I think we're very much in favor, and we'd love to see that, Micah. So great. Next on the agenda is pod IAM credentials cap from and who
yeah. So I can introduce this, but I think if Paul is on the line, he could do most of the talking. I'm not sure if he's here, but so basically we're trying to solve the problem of getting IAM credentials to pods. We talked about this a little bit in the previous SIG AWS. But I'll just sort of go over some of the basic approaches that various people in the community have thought of. So one of them is using EC2 metadata. And there's two approaches there. There's a couple. So that you either proxy the EC2 metadata to the pod, you re-implement the EC2 metadata API parts of it, and then make the call again. Or another sort of different approach is to do, this would require some SDK changes, but to use like a secret, have a controller that populates a secret with temporary credentials, which the SDK doesn't currently support. But there's a Mikkel Oscar, I think his handle is, he's forked the SDK and proved that it could possibly work. So the proposal, the KEP that was just written, is sort of an iteration of a project called KIM. And so it's one of the EC2 metadata approaches. It started as running, so there's an agent which in the original work ran as a daemon set, and then there's a server. And so the server, so the daemon set pod requests credentials from the agent, I believe, and then the agent forwards it to the server. The validation is done on pod IP. There's mutual TLS from the agent to the server, and the server actually makes the request does the assume role request and then returns the credentials back to the agent, I believe. And correct me if I'm wrong, if anyone on the call has a better understanding. So if anyone wants to dive in and explain that a little bit better, I was just going to raise some concerns with the KEP that I specifically had. But right now, I'll just open up the floor for anyone else to add to that.
I have concerns over the caching that goes on, but I think at a high level, I agree with your summary. I think if we get into the details of the caching of roles, there's some non-repudiation type use cases in CloudTrail that concern me a little bit, but I think that's lower level than where we are right now.
Right. Okay. Yeah. We'll get there. Yeah. So the caching of the roles that you're talking about is happening at the agent, which is running as a daemon set in KIM.
Happens at the server. So the server caches
right,
the
the
roles
server,
on the watch.
yeah.
It does use a watch, so that's very nice. It uses a watch to do the cache. So watches new pods show up, and then as they show up, it caches roles, but it's one role for all of the pods that come up in that particular pod spec.
Right. Okay. So if I remember correctly, you were advocating for the new KEP has a sort of, instead of using a daemon set, it has a sidecar and an init container. And so like my concerns are kind of injecting that into every single pod is a bit of a burden on the user. So from more of an operational standpoint and just, I don't know if for example, from EKS's perspective, I don't know if we want to be injecting a bunch of containers into every single pod.
From like a user's perspective, that would just confuse everybody that's trying to just be a customer of the cluster too, right? Like we've got, I don't know, a few hundred engineers that are trying to use Kubernetes. They expect to get what they put into it. And if you start mutating what they're doing, it confuses them.
Totally, yeah. So, so there are some, Mike, maybe you could talk to some of the benefits of that approach.
Yeah, the issue, I agree. I don't like the fact that I'm forcing a sidecar container in there. I don't like that. The challenge I'm having is how do you actually get unique identification capabilities? Because if I don't do something to get the service account right now, I'm struggling to get a unique pod ID. So let's say you have hundreds of users, deploying thousands of containers, and two get compromised. If anything happens that actually starts to go down the line, your forensics team can't actually tell you what data you lost. And so that's a big issue for a financial services company.
Right. So
is it a problem to allow the node to attest the pod that it's like if you had the proxy running on the node, do we not consider that if the node attests I'm making this request on behalf of this pod, and I know that pod is running on that node, is that not good enough?
So I'm very interested in that. And I guess my question is, right now, what's the attestation you're using? Because I'm curious if I get that service account token out of the pod and it leaks out into the node effectively to go across the wire, do I have any concerns there? Is the community going to tell me?
Well, I mean, it's already on the node, right? The node is the one that's actually putting that token there. So I don't think that we need to worry about the node gaining like replay credentials for the pods that are scheduled on it.
So so that puts us running on something next, like the ECS agent, something next to the kubelet, right? In that model? Yeah. No, yeah. I think at the end of the day, I expected EKS to end up there. And so I'd be happy if we ended up there before EKS did, actually. I just didn't know who wanted that impl, because now if Amazon's going to take that back upstream, or if we're going to be in a little bit of a fork version there.
Yeah, I think we want to, EKS wants to be as similar to the community solution as possible. So if we can do the daemon set approach and bootstrap identity with the service account, I like that approach.
To my mind, they actually aren't that different. In other words, like the most, like 90% to say of the code is going to be the same, and then you could have like two separate configurations, one of which runs as a sidecar pod, one of which runs as a daemon set, I think. And there's like a little bit of like look up to be like, how do I get the service account, right? Do I just pull it from my local file, or do I look up the IP and do that sort of thing, right? So I don't want to rat hole on that too much. If we think there are two viable configurations, that one of which is like we don't love the sidecar pod, and the other one of which is maybe some people don't want to run a daemon set because maybe it's a little bit less secure, then we can maybe support both, right? I don't see them being that fundamentally different.
I actually have some security concerns about the sidecar. The sidecar approach relies on rules that live in the pod's network namespace in order to do that interception of the metadata API. So any pod that runs with capnet admin can override that and then send its request presumably to the real instance metadata API, and then like assume the credentials for the node, which is bad.
I do think separately we should lock down the instance metadata access from the node.
Well, the other thing is that what you want to do is intercept just the credentials and allow other kinds of things to go through, because like a pod may have a legitimate reason to know what zone, or like what availability zone it's running in. And so as soon as you're saying, okay, we're going to allow particular HTTP requests to go through and other ones to be blocked, like you're running a proxy on the node, right? Like that's just the situation that you're in.
I agree with what you're saying, Spike. A quick question: do we have any interest in separating the concept? ECS separated the concept of that metadata URL, but there's actually two real URLs. There could really actually be that container metadata URL that might provide us some of that information, and there might still be an actual node metadata URL.
Is the container metadata URL at a different authority, like a different?
It is
IP?
right now, right? I just don't think I haven't heard the concept broached where we actually say, hey, these are actually definitively different things. And I have a use case for both. Like the node actually has a use case for that metadata URL as well. And the containers have a separate one. We blended them together in ECS because Amazon gave us a nice solution where it worked, right? But now I'm looking at us as a Kubernetes operator where I have to operate these nodes still. I feel like there's actually a unique use case for both of them that you're really bringing to light there.
Yeah, so if there's a different authority, then you can do it with IP tables and block access to the EC2 like node metadata, but would allow container metadata stuff, and then you don't need to run a specific proxy. Or you could get away with just a sidecar, and then if the user sort of ripped out those redirects from the sidecar proxy, they would just get nothing back from the node.
But I guess from the rest of the people on the call, is that in Amazon in particular, are we off the reservation in the concept of thinking there's two unique use cases for those metadata URLs, or are we in line with some of the thinking from you guys as well?
No, I mean, if I have to be secure by default, right, the pod really cannot be reaching into the instance metadata URL, right? Because, I mean, if you could have two different endpoints to talk to, but if the pod hasn't access to the instance metadata URL, it could get the credentials of it, right? The whole idea being you don't want the pod to get the instance credentials, right? So which means that you would have to go the route of blocking the instance metadata in addition to providing the secondary endpoint that you're providing to the pod.
And just to check, because I'm a little fuzzy on this, the Amazon SDKs support getting credentials from this second endpoint?
They should now. There was a gap in the Go one a few months back, but I haven't had any issues recently. Because like if anybody was running Packer, you found out they had an old AWS SDK and the code build API didn't get it because code builds on the ECS metadata URL.
Okay.
What is the second endpoint out of interest? I haven't seen this yet. Is it a different IP or?
Yeah, it's 170. I can't remember but it's not 169. It ends in a 170, I think.
Okay, cool.
Yeah, there's a section called Intercepting AWS APIs where we actually do say to you that we will present the ECS metadata IP address, not reproduce the instance metadata. Is it helpful? Should we actually talk formally in that CAP around like issues around non-repudiation and things like that? Because I think those are going to be where you might make that decision around using a daemon set versus something else. And maybe if we just document those choices clearly, then for you, particularly use case, it's the main issue.
Yeah, I think you should definitely document those.
Yeah, I mean, a security considerations section in general is a good idea, especially for this where we're talking about accessing credentials.
But besides the KIM server, I know there's a lot of Vault use cases in this category. Would we want that agent to support both the KIM server and something like a Vault solution, or is it unnecessary to have that configurability?
I'm not sure what you mean by a Vault solution. Like a Vault solution for getting AWS credentials, or for getting generic credentials?
For getting AWS credentials. So Vault has the STS API in it as well. And so we could, if we chose not to run KIM, we could run Vault outside the cluster. And I could configure that agent to, instead of talking to the KIM server, I could configure it to authenticate to the Vault cluster using its Kubernetes auth method. and let Vault do the assume role. There's some advantages some people might argue are in there, being the audit trail is now synced to Vault, and if I had a large corporation running Vault, I have one audit trail. And I know what that audit trail looks like, and it's encrypted and protected all in the same fashion. But it would require additional configuration in order for us to do it, and it would require service account token, whereas KIM could work without service account token. So it's definitely not a free add.
It might be nice to have the protocol documented, right? I don't know that we could reuse this so that Vault could use the same thing, or we could have a bridge, but I wouldn't necessarily. I wouldn't. We could try to use the Vault protocol. That feels overkill.
No, I wouldn't want to use the Vault protocol. I would. Well, yeah, I agree with you. I was trying to figure out how much adoption there was in the community, because if there's not much, then we can wait till someone asks.
There is some concern though over using those service account tokens for this kind of attestation, because they're replayable, and so like ideally we would have a solution that doesn't suffer from that drawback, like mutual TLS or something like that. But I mean, your point is that, well, Vault uses those, and so if you want to integrate with Vault, then you need to do that. But there's some downsides to using those tokens.
In lack of those tokens, what else are we using for container ID effectively?
Well, you could have the node authenticate itself to the server, and then it could just make an attestation saying this is on behalf of this container. And then the server is watching the Kubernetes API and knows that container really is running on that node, and then we could call that sort of good enough. That's basically all we can do, because ultimately every credential that you put into a pod is put there by the node in the first place.
One thing that we actually sort of discussed just as a concept, nothing fleshed out, just still very early in the design phase, was to use, if you could use the service account token, this is a lot of ifs, but if you could use a service account token, and if Kubernetes was an OIDC provider itself, you could use AWS IAM Federation, because IAM supports OIDC as federation. And if you could use that service account token hypothetically as the federation token against the STS API, then essentially a service account token becomes an IAM identity in itself, or can become an IAM federated user, right? There's a lot more thought and work that would need to go into that, but that would you could add potentially a very small change to most SDKs, kind of like how ECS did with the metadata, but to use that service account token as a federation token against STS.
Yeah, and it would use the STS assume role with web identity, and then STS would, I guess, identity provider would be the Kubernetes API server.
So that means that we're no longer proxying the metadata service, and instead the pods just talk directly to STS. So that's a much bigger change to the SDKs. I wonder if anyone from Amazon wants to weigh in on the feasibility of that. I guess we already saw at least kind of one problem where projects were built with the old versions of the SDKs and then deployed in Kubernetes and didn't work. Is that actually a viable route to say, okay, we're going to update all, like there's not just one, like we're going to update all the SDKs, or is that a non-starter?
So it's not that it's not possible. I did have a conversation with the member from the SDK team specifically about using the refreshable secrets, and that was sort of it wasn't a non-starter, but they were resistant to it. So we would definitely have to have a conversation with them and push for it. So it could be a long process.
But there is precedent already in Amazon, as you can see, like to have a second metadata endpoint that ECS pushed. So I do think that it's possible, but I think if there was support for it in Kubernetes and it was a good idea and it had been vetted and everything, I think that could happen. But like you said, it would take time. You'd have to have all the SDKs updated, applications that you would have to use the newer SDKs that have that. So that is one of the risks of this.
So that has some nice properties because there is work in the Kubernetes pod identity working group to make those tokens that are issued to pods more useful. Make it so that they actually have an expiration date, that they have an audience, things like that. But it's going to take a while for Kubernetes to actually support that. And so I don't know what kind of time frame people have to get something working and blessed here.
Yeah, this might just be a longer term idea, and we might have more intermediate term solutions in the meantime.
So we also liked the OIDC solution at Intuit. That was one that we liked. We went away from it after some conversations that IAM was going to kind of rule the auth pattern here, we thought. So I kind of shared that with Nick yesterday when I met with him up there. Well, I'll say it again here. Like if we were to go down an OIDC path as a long-term solution, I think we would be interested in figuring out where that was going.
All right, well, I think we should probably call time on this topic because we still have a bunch of other things. I think there's a great cap. I'm very happy to see that. Thank you for doing that. And let's continue the conversation on the cap. And yeah, the next item I think is not entirely unrelated. So it looks at the authenticator plans. So the IAM authenticator, which is different from what we just discussed, which is IAM into the pod, credentials into the pod. This is, I think, using credentials to access the API, as I understand it. So who is this?
That would be me. So I put this proposal in, and I kind of want feedback on the design before I actually dive into the code. I started building out a proof of concept of it, and I've done a couple iterations of it. But the idea here is the current structure of the IAM authenticator uses a config map that mounts a file directly into the root of the backend webhook server. And what ends up happening is every time you do an update to it in the open source project, you have to go and actually reload the daemon set to actually make that apply across the whole cluster. So you won't have roles applied to or allowed to authenticate unless you go and restart everything that goes on the API server, which obviously creates blips in the authentication for your cluster. So this proposal is pretty much just using IAM identities as a CRD and sets the webhook authenticator to basically watch that resource and re-update its internal cache every time there's a new role added. Because it uses the CRD design, we'd be able to also put restrictions similar to what we can do with config maps and tagging down to a specific resource on who could mutate this and create new roles. And yeah, that's about it.
Yeah, I think it's a really solid idea. I like the sort of validation that we can do. So EKS as a stopgap had gone with a config map wherein the role bindings are laid out in just in the config map key values. But I think I prefer the CRD proposal. The only issue that I had with it is I'm not completely sold on the pattern that you have of the two different custom resources.
I updated it. It's now only one. Yeah, based on Matt and your feedback, it's all contained under that IAM identity resource, so it'll be even simpler to pull in now.
Gotcha. Cool. Awesome. Yeah, if anybody's curious about that, maybe you can describe what the resource looks like now.
Yeah, here. It basically is just, it has a spec key under a spec. Underneath that, it has the same keys that were defined in the config map. So a role ARN, a username, and then the groups associated with that user. I think the resource would be called an IAM identity under, I right now have it documented as authenticator.aws/v1alpha. There's not much else to it. It's really simple.
I think it looks good. Do you own the AWS TLD, or did you make that up?
We own the AWS owns the TLD.
That's very cool. All right, I was just like, what? I think FYI, I think config maps do reload, do update on disk, but it is asynchronous, and you have to like check it manually. And CRDs are much better, but just for the record, so that people know that should happen.
The problem with with how we have it structured is it mounts a file into the root of the project, and since it's Go, it just basically loads it all into memory and never reloads that file off of disk, even if it does update.
Yeah, you would have to change your Go code to like reload it. But yes, I just wanted to make sure people knew that happened. But yeah, CRDs are definitely the way forwards in general, and even even preferring CRDs to the Go defined types, like more formal types, and CRDs are getting validation and version. Well, they have some validation now, and they're getting versioning and all these sort of things. So yeah, CRDs are great, and to the extent that they have shortcomings today, the gap will get smaller over time. But certainly, they're better than config maps already today in terms of structure and working with the tooling and all that. So yeah, I think this is a great suggestion. As you say, yes, there is a migration issue, but it's a relatively new project, so I think it's okay.
Yeah, and Matt pointed out in there, and someone pointed out, I can't remember who it was, in the actual issue for it, that Prometheus operator did a very similar thing. Steven did, and they basically provided a CLI tool that you can do, that you can regenerate all of your CRDs based on the config map from that Prometheus operator. So that could be a potential for helping anybody that's already using EKS or this in their open source distros.
Or you could continue to mount the config map for now and
yeah, load them both.
Tell people, hey, it's going away, but cool. That sounds great. Yeah, that would be great I'm excited to see that. That's great. Thank you.
I wanted to bring up two other things about the authenticator. So right now we have these in the mapping and the username, and I think you can do it in the groups too. We have these sort of templatization or template variables that you can use, like session name, EC2, private DNS name, account ID. And so since we're already looking up, for example, the EC2 private DNS name, we get the get caller identity back, we get the instance ID from there, and then we, in EKS, we assume a role to look up this because it's the customer's account. If you were just running it in one account, you would just do the lookup. One thing that I was wondering is, so right now you can only specify groups in the mapping itself, but AWS does have a concept of groups, which are just collections of users. Would we want the ability to automatically attach those groups to like translate them into Kubernetes groups, or are there any reasons that's a bad idea?
Sounds useful.
Yeah, we already have, you could have a systems masters group in AWS, in your AWS account with its own permissions for the AWS APIs. I don't know, just a thought. If anybody has feedback, maybe I'll open an issue or something. But.
I'm just trying to think whether he has anything comparable that we can think about. I don't know.
How else could you accomplish this? Like, if you're doing this bridge of IAM users into Kubernetes, how else can you group them?
A role that everybody assumes or could assume.
Meaning that you have a role binding that just enumerates every user that's allowed to use that role.
From the IAM perspective is what I'm getting at. You could have a role that that would act as a group.
I'm a little fuzzy on the actual details of how this authenticator works, right? You're logging in to try and talk to the API server. What does the API server get? Does it get the role that you've assumed, or does it get the username?
Yeah, so it gets the authenticator returns so the authenticator actually gets an STS get caller identity request that was signed, but not sent. It sends it. It gets the AWS identity, which is the role ARN essentially. So it could be a user ARN, a role ARN, and then it looks up in the mapping the user name and groups associated with that user and returns that to the API server.
Okay, so the authenticator itself contains this mapping layer.
So the authenticator itself has to be able to look up, like I think groups only apply to users. So if it got a user ARN back, it would then have to say AWS IAM get groups for user and then send those back.
I guess what I'm asking is, when Kubernetes receives a request, the groups that it receives today, not before any of these proposals, are there any groups? Where do those groups come from? Are they just configured in the authenticator, or is there some other way that you can put users into groups?
So in Kubernetes itself, I'm not sure if I understand, but Kubernetes itself doesn't have a concept of groups, right? It gets users and groups from the authentication system.
Yes.
So
using this authentication system today,
yeah,
what are the groups and how are they defined?
So there's a mapping in the config.
Okay, it's just in the authenticator config.
Yeah, it's just an authenticator config. It doesn't come from anything else.
Okay.
So this would actually tie it into your AWS groups.
Yeah, which sounds better to me rather than like fragmenting your definition of identity and groups into this authenticator and IAM.
Right.
Okay, I think you might need some mapping, but I think that sounds great, and I think it'd be cool to look into and play with. There are a couple of other things on the agenda, so let's keep going if that's okay with everyone. Next up, Seth, building SIG AWS projects with ECR and code build.
Yeah, I just wanted to start a discussion about that for SIG AWS projects, like how we're going to build them and, repos for them and stuff like that.
Yeah, I mean, I think it's super important, I think, to have some way to build our code in a way that we can trust, and that I know that the main Kubernetes repo, Kubernetes itself, has recently switched to add some tooling. So there was a tool called Anago, which was basically a shell script, and I think it's recently been made so that it will work on GCP, Google Container Builder, which is sort of like the Google's hosted build service. And I think it'd be great to have Amazon's one as an option as well for all our projects. I do think it would be great to have a world where we have multiple people building the code, ideally in an automated fashion, and they produce the exact same SHA, right? So that we know that if you wanna like compromise the code, you have to like break Google and Amazon, which is a lot harder than just breaking one. Even breaking one should be very hard, but like breaking two feels very, very difficult. And so, I would love to see that. And Seth, I don't know if you're actually going to work on getting it building in code build, but that would be wonderful.
Yeah, I guess I'll start with the Bazel stuff first, and then I don't know. I guess we have to figure out how to get access to code build.
Yes, and I think there's two things. One of which is you want to have a bunch of accounts which are running, which do the builds and don't necessarily have to sign them, but at least produce the builds, and then we can look at the various builds and make sure they're the same across the builds. And then the other one is we need some sort of trusted party that goes and like holds the signing key or holds the credentials to push it to the official GCR repo or the official ECR repo or the official like buckets or whatever it is. And that one needs to be a lot more secure, obviously. So I feel like the first step is to get it working in GCB and getting it working in code build and getting it working in other things, and then we can go from there. And there was a Bazel bug or there is a Bazel bug where the builds are not reproducible right now. So the real problem is, I think, getting reproducible. If we like this approach, one of the real problems is getting reproducible builds to happen at all. That's sort of pretty non-trivial, and Bazel makes it easier. There is a bug right now with the Go build with C builds that they are not reproducible. I actually tracked that down last night, so hopefully that will get fixed in the next version of the Bazel rules Go. But yeah, I want to write up this sort of idea of how to do the builds, but it's definitely an interesting topic that I don't know if anyone has any input on how we should do builds in the project, but I think we need to get away. Like COPS is built like on, a machine that I spin up temporarily, right? An ephemeral machine. And it's nice. It would be better if that was built in a more automated and trusted fashion. And I think the same applies to all of our projects. But otherwise, yeah, it'd be great if Seth, if you want to do some stuff on it, that'd be great. And I'm also working on it, so we should collaborate a little bit on that and figure out what we can figure out.
Okay, sure. I'll reach out to you.
And the next one is also one of yours, Amazon Linux 2 in Seth, Amazon Linux 2 in COPS E2E.
Yeah, that was just a question for you if that's currently happening.
I actually can't remember whether I did it or not. I'm guessing, given you asked the question, that I didn't do it. It's not hard to do, but I will. We could do another video where we do it together and we talk about where we talk about like how the system works. If you want, that could be a fun one. It's not a terribly hard thing to do though. But yes, we should definitely get it under testing, and yeah, we should get under testing.
Okay, I'll reach out to you about that too.
Awesome. Good. Last item on the agenda, Jan. Sorry. Oh no, one. Yeah, I think that's one item. The CSI driver requirements and design.
Yeah, I put this document a while ago, and I'm looking for a reviewer, especially from Amazon. I need somebody who understands the volumes and especially the attachment, because the API that Amazon provides for attachment is quite different to anything else that Kubernetes supports. And the thing that Kubernetes or the CSI driver has to choose the device and do that reliably and resilient to errors and to restarts and everything, it's quite difficult to do it right. The current code we have in Amazon does it wrong. There are some corner cases where it gets stuck or it refuses to attach volume. So it would be great if there was either existing library for attachments or the Amazon itself could assign device names, because basically we don't care about device names in Kubernetes. Yeah, so I'm looking for a review or suggestions how to do it better than it is now in Kubernetes.
Yeah, I think we should get some folks from the EBS team to review this one. So if maybe someone on the Amazon side could take an action for that.
Can you guys hear me? Am I muted? Hold on.
Yeah.
Can you hear me?
Okay.
No, mute your.
I don't know what happened there. We can no longer hear you.
Oh. Can you hear me now?
Yes.
Okay. So your proposal, Jan, is being reviewed by the EBS team right now, and also a couple of engineers from the EKS team. So if you can give us a week, we will get some comments back to you.
Yeah, that's great. Thanks a lot.
And you can reach me and I'll connect you and give you an update on it.
Yeah, sure. I have a guy here in our head who is slowly implementing, but really, really slowly. It's not the topmost priority, but it's pretty high. Okay. And I think we can send some patches, some first implementation of some first course pretty soon. I'm not sure it's going to be next week, but maybe a few days after that.
Okay. Okay.
There are also the new NVMe volumes which don't have this requirement, right? And I don't know to what extent anyone is prepared to comment on whether that is the future or whether we will still need this code in, say, 2 years for like not whether every instance family will have NVMe or whether we'll still need this code in future.
But that's very Flash specific. It's very complicated to talk about.
I don't know if we're supposed to hear you or not. Sorry.
I need to research before I say something.
Anyway, yes. So anyway, if yes, the NVMe the allocator that's in there dates from when the allocation was done on each node. So it would not terribly surprise me if there were issues once it was moved to the controller manager. And even it had issues even then. So thank you for all the help on fixing those issues, Jan. But it will be easier with the NVMe code in that you don't have to assign a device name, device mount point. It is sort of inferred from the volume ID, which also means that there's no chance of a like crosstalk, I call it, where you like get confused and mount the wrong volume. It just can't happen because the name includes the volume ID.
That's interesting.
And we do have support for that now. So in the cloud provider, so there it is better. Feels more reliable as well, but you know, fingers crossed.
I think we're going to have to support non-NVMe for some time because not everyone's going to use Generation 5 instances.
I think that's true. It's a matter of like priority of like tracking down every edge case, I guess. But yes, certainly today it's not across the board that NVMe is like universal. I don't know if anyone else has anything on the agenda. Let me just see if anyone put a last. We reached the end of our agenda. Is there anything else? Is there anything else anyone would like to add? Wonderful. Well, I wish you all a happy Friday and a happy weekend. I don't know if anyone's taking a long weekend or week, but happy weekend. And talk to you in 2 weeks.
Thanks. Bye.